Hello students, now we are going to discuss about the acidity of the alcohols, acidic strength or acidity of the alcohols. Now the general formula of alcohol, general formula ROH. This is the general formula. Now then after removal of H plus ion, how to identify the acidity means it depends on the releasing capacity of H plus ions. H plus ions. After removal of H plus, this group converts into RO minus. This RO minus is generally called it is alkoxide. Alkoxide ion, or another name is called conjugate base. The other name is conjugate base. This one. So that means the acidic strength of alcohol is depends on this stability of the alkoxide ion. So that is the main condition for this acidity of the alcohols. The main important point here, acidic strength of alcohols depends on stability of conjugate base, or it is also called alkoxide ion. Okay, alkoxide ion. So in these cases, majorly we will depend with the stability and the acidity both depends on the alkoxide ion conditions. Alkoxide ion condition only. Then generally we know that the formula directly I gave already. If a plus I group is attached to this alcohol, now the acidic strength decreases or acidity decreases. If a minus I group is attached to the alcohol, now acidity increases. Okay, so these are the conditions. So based on that, so now I will explain the simple example. First one only, simple one. Or CH2OH. This is the alcohol. Second one, or CHROH. Second one. Next, third one, RCROH. Tertiary. It is a primary. It is secondary. This one is tertiary alcohol. In these three alcohols, so the acidic characteristics depends on the ability to release H plus ions on the given alcohol. Now, in this given case, after removal of H plus from this, now we will get this one is RCH2O minus. From this, RCHO minus R. Here, RCRO minus. So this one, in the first case, one alkyl group is release electrons towards this alkoxide. Here, two alkyl groups. So these are releasing the electrons. Now in this case, totally 3. Like this. That means Here density increases more. If the negative charge increases more, what about the stability decreases? If number of alkyl groups or the releasing groups increases, here stability decreases. So which one is more stable now? This first one is only more stable. If stability is more means that alcohol, which one easily release the H plus ion? Now this group easily release the H plus ion than secondary. Secondary is more effectively release H plus ion than tertiary. This is the acidic strength order also. Very, very important. So here stability is more means acidic character also more. Now here we can write stability is directly relation with the acidic strength. Okay. So stability more means acidic strength also more. This is the one kind of formula. Now by using this, we can identify the acidic strength of the alcohols. Okay, we will discuss few examples on this. First one, first case, A CH3OH, methyl alcohol. Next, second one, CH3 CH2OH, ethyl alcohol. Third one, CH3 CH CH3OH, isopropyl alcohol or secondary alcohol. Next, fourth one, CH3 C bond CH3 bond CH3 OH. So this one is a second tertiary alcohol. Okay. So in these four cases, which one is more reactive towards sodium metal? So which one we have to identify this? More reactive towards sodium metal. Towards sodium metal. That means alcohol in the presence of sodium, sodium easily replaces the H plus ions. That is the meaning. Now, first we can identify by using this which one is the most stable compound in this. Most stable means here one group directly CH3 group attached to alcohol. Here CH3, here hydrogens. Here how many? CH3, CH3. Here also 1, 2, 3. Means 3 plus I groups attached here. In this third case, 2 plus I groups. Here 1 plus I. Here hydrogen atom. So hydrogen. Compared to these all cases, D has more number of releasing groups. If releasing groups increases more, plus sign, now that stability decreases at the same time, acidic strength also decrease. Now, which one is more effectively reaction with sodium metal? A is more effectively than B, B is more than C, C is more than D. So this is the reactivity also. Reactivity. Now, in this case, we can write reactivity of methyl alcohol is more, that acidic strength also more. Okay, this one is the reactivity and acidic strength. So here reactivity means towards the sodium atom. Okay, this one towards sodium metal. Okay, towards sodium metal only reactivity. So like this, we can easily identify the acidic strength of the alcohols. The next one simple, uh, small classification about the alcohol I will explain. If the cleavage of a bond depends on the given alcohol group, R, O, H, this is the alcohol. In this, now I'm dividing into two parts. It's based on the cleavage only. First one, cleavage of OH bond. Next, another one is carbon oxygen cleavage. These two. Okay, carbon, oxygen also. Write these two. In these two cases, if carbon oxygen hydrogen bond is broken, that means if you break the bond in between the oxygen and hydrogen first, then this group converted into alkoxide. Alkoxide ion. In these alkoxide ion, it forms majorly one is a primary, secondary, tertiary groups. Okay, same as like if you break the bond in between the carbon and oxygen, carbon and oxygen, then this one forms carbocation. Carbocation forms. Then this one also converted into primary, secondary, tertiary groups. So in these given conditions, which one of the following is more stable after breaking of oxygen and hydrogen? Here, the group primary only more stable than secondary, secondary more than the tertiary. This one is the cleavage of OH bond. Then if you identify in this, here also three primary, secondary, tertiary carbocations only developed after cleavage of carbon and oxygen. Then which one is more stable always? Tertiary carbocation is more stable. The difference in the cleavage of bond occurs in alcohols. So this point also very, very important. So based on the given condition, we should apply which one is a more reactive and which one is less reactive. Okay, that condition, one example now. One example. Suppose first one C2H5OH ethyl alcohol. Next CH3 CHOH CH3. Second one. Next third one. Another case also here CH3 CH CH3 CH2OH isobutyl alcohol. Isopropyl alcohol in the second case, third case isobutyl alcohol. Next third one, fourth one CH3 COH bond CH3 CH2 CH3. So these are the four compounds given. So in these four compounds, which one is more reactive? More reactive. More reactive towards HBr molecule. This is the condition. Towards HBr. So HBr here alcohol given. Here also HBr molecule. HBr is acid, it releases H plus ions. So OH eliminates in the form of H2O molecule, water. After elimination of a water molecule, that is important. After elimination of a water means which bond will breaks here? carbon oxygen bond will breaks. This bond will breaks. This one. Okay. After elimination. So which one is more stable in this case? More stable. That is also important. So the stability of the D is always more stable. So we can write D is more reactive towards HBr. So after that, here primary, here secondary. Which one is more stable? Secondary only more stable than C. Next A. So this is the order. Okay. Reactivity order of given compounds. So in these given compounds, it is a more. Next one B, C, A. This is the reactivity order of alcohols towards HBr molecule. Then next we will discuss few acidity or acidic strength of the alcohols. Next example. First one CH3, CH2, OH ethyl alcohol. Next second one CH2, CH2, OH, here fluorine. Next third one CH2, CH2, OH, here NO2. Fourth one CH2, CH2, OH, here NH minus. Fifth one CH2, CH2, OH, COO, H given. So which one is more acidic in this all cases? So this one also very important. So here we are asking about alcohol acidic strength. Alcohols. So alcohol's acidic strength means we can write directly the group which is containing either electron releasing group or electron withdrawing group. So electron releasing or withdrawing group conditions here. First group, it is directly electron releasing group of this totally. But in this case, one fluorine atom, it is minus I. Then next after that, NO2 also minus I. NH minus is plus sign. Next one COH group is, it is minus I. So minus I groups 2, plus I groups 2, minus I groups 3, plus I groups 2. So generally for alcohols, plus I decreases acidic strength. What about the minus I? It increases the acidic strength. So which one more acidic now? Second, third, fifth compound. In these three, which one more effectively withdraws electrons means NO2 group only withdraws. So more acidic compound in this three is more acidic than next COH and fluorine. Which one effectively withdraws means COH group only withdraws. So 5, next 2. Next coming to the first and fourth condition. Fourth, NH minus effectively release the electrons. If it is effectively release electrons towards this oxygen, here density increases more. Electron density increases. If electron density increases, what happens? The bond strength increases more. Bond strength increases. If a bond strength increases means it is unable to release the H plus ion. So the acidic strength is least. So one is more than the fourth case. So this is the order of acidic strength of alcohols. So this is important case only. Okay. By using this, we can identify the acidity of the alcohols. Next, coming to the acidity of the carboxylic acids. It is also another very important acidity of carboxylic acids. Okay. So general formula RCOOH. This one is the carboxylic acid's general formula. Then how to identify the acidic strength of the given carboxylic acids? Now, generally, if you identify RCOOH after removal of H plus, it converted to RCOO minus. This one is conjugate base of this acid. It is acid. This one is conjugate base, or it is also called carboxylate ion. Carboxylate ion. Then before also we discussed one case, same as like the acidity of carboxylic acids. Acidity of carboxylic acids depends on stability of which one? Carboxylate ion or conjugate base. Carboxylate ion or conjugate base. So this is the condition. If you know this condition, we can easily identify this. Then based on this condition, if the releasing group is attached to this carboxylic acid, what happens here? If a plus I group is given, then acidic strength is decreases. Same, just now we discussed here, decreases the acidic strength. If a minus I group is attached to that carboxylic acid, it increases the acidic strength only. Now, on the basis of these two formulas, we can easily identify the stability and acidic strength of the carboxylic acids. So, generally, we can express the acidic strength values in Ka and pKa. Okay, acidic strength values we can express in Ka and pKa values. That means the Ka is directly relation with the acidity of carboxylic acid, and pKa is inverse relation with the acidity of carboxylic acid. And what is the relation between the Ka and pKa? Both always inversely relation. Always inversely relation. These also very important. These three cases also important. Ka is inverse relation with pKa. pKa inverse relation with acidity. Ka is direct relation with the acidity. If you know these conditions, we can write Ka, pKa increasing and decreasing order of the carboxylic acids. So then Ka condition means in chemical equilibrium chapter, we will discuss very clearly that suppose here when carboxylic acid reaction with water, reaction with the water, this group converted into RCOO minus carboxylate ion plus H3O plus, H3O plus only. Now here this group alone it acts as a acid, it is base. Now the acid here gave RCO minus is the conjugate base of that acid. Then base here converted into H3O plus. It is a conjugate acid of this H2O base only. Okay. Now, so how we can write by using this? According to the equilibrium conditions. According to chemical equilibrium. So K equilibrium is equal to concentration of the product RCOO minus into H3O plus ion conjugate base and acid concentrations by concentration of acid RCOOH into concentration of water molecule. So the concentration of water molecule is always a pure liquid. The remaining conditions are aqueous condition. Now, if it is comes to left hand side, this water molecule concentration, so K equilibrium into concentration of a pure liquid equal to, we can write concentration of RCOO minus into concentration of H3O plus by RCOOH carboxylic acid. Now, the product of equilibrium constant K and pure liquid water, both constants. Now, these two constant only. The constant we can represent it with one new constant value Ka. So, this is acid dissociation constant. We can say that one it is acid dissociation constant. This one. So this is the Ka. Acid dissociation constant. So this one only. So acid dissociation constant, Ka value. If Ka value is very high, so the acidic strength is very high. Acidic strength is very high only. If this value increases means here the product formation is more. So what is the meaning here? Now Ka value increases, conjugate base formation increases. Listen clearly. Ka Ka value increases, conjugate base formation increases. That means what? Conjugate formation means acid dissociate into product. So acid to product formation. So acid to product formation. So which is here release the H plus ions easily. Release H plus ions easily. When the substance or the group which is release electron H plus ions very easily means the acidic strength is very high. So because of this reason, we can say that Ka is directly relation with the acidity. That is the condition. So we can say that by using this acidic strength of the carboxylic acids. So the carboxylic acid generally same depends on the plus and minus I groups. So that conditions also we will discuss now with examples only. So one example, first one, H C double bond O OH. This is the one example. Next, another one is CH3 C double bond O OH. Second example. So in these two, which one is more acidic? How to identify that acidic strength of the given molecules? After removal of this one, H plus ion. HCOO minus. After removal, this one also CH3 COO minus. Here hydrogen group is given. This hydrogen group, it is neutral. It is neutral. But here CH3 group is plus psi group. If a plus psi group increases the density on the oxygen, it is unable to release the H plus ion very easily. So we can say that this formic acid is always more acidic than the acetic acid. So this is very, very important. After removal of H plus, which one easily remove the H plus ion? This formic acid easily removes H plus or release H plus. Then which one? Acetic acid. So formic acid is always more acidic than the acetic acid conditions. Okay. So like this we can explain the acidity of the carboxylic acids. Okay, students, in the next video, we will discuss more number of examples. Okay, thank you.